When we work with composition functions, we also will find ourselves having to deal with domain and range, values that do and don't work, and what acceptable outcomes we get. Remember, when we talk about domain, we're talking about numbers that I can use in the given function. So for example, if I look at f, any function number I want to insert, any real value, will result in a real value coming back out. I can plug in any real number for x, I can multiply it by 3, and I can subtract 1, and I'm going to get a real number answer. So in the case of f, my domain, so the domain for f is going to represent all the real numbers. No restrictions. I can also write that, another way to write that in set notation, so the domain of f represents all real numbers. Any number I want will work. Now if I look at g, that's going to be a little bit different. The domain g, there are only so many values I can take the square root of and stay within the real number system. Now I know we've talked imaginary numbers, and those are the exceptions. When I want to talk about numbers in the domain, I'm restricting myself to real values. So what are the numbers I can use for x that will result in a real number answer for g? Or rather, if I were to write this, g of something, what numbers can I use here which will result in a real number output? Well, when I look, I've got a square root. I can't take the square root of a negative number and have a real number answer. So my domain is going to be restricted to the values of x such that x is greater than or equal to 0. So what I'm saying is I'm allowed to use all the positive numbers. I'm saying that x must be greater than 0. You may also see this written in some textbooks as x cannot be less than 0. And that's the idea of, instead of saying what it is allowed to be, we're going to set up restrictions as to what it cannot be. This is going to be important. When you do composition functions, you need to be aware of the domain, the limitations, from the original two functions. So for example, let's say I want to do the composition of g on f. Now I know that that's the same thing as saying g of f of x. So I'm going to replace the x in g with what f is. Simple enough. So I take this expression up here. G is square root of x plus 2. Another approach you could use is I'm going to write down my function that is g, so square root of x plus 2. I'm going to replace the x with what f is. F is 3x minus 4. Now there's no simplifying to be done in this case. This is all inside a radical, so I cannot add this outside 2. If the 2 was inside the radical, or if this 2 was in here, then I could do the 4 and the 2 and combine them. That would look like this, square root of x plus 2. See how it's inside the radical? That's not the case here, though, this case here, so I don't need to worry about that. Also, as a small pro tip, that little tag tells me where my radical bar ends, tells me what's in the radical and what's not. It's a very useful skill for good bookkeeping if your penmanship isn't spot on. You'll notice if you've been watching over the year, I've been pretty, well, my penmanship's not spot on. So, now, when I look at this function, the g of f of x, are there values that would make this negative? Because that would break it. When we talk about radicals, we want to know for what values this thing under here is going to kick out a negative number, which would result in an imaginary solution. So what I'm going to do here is I'm going to say, well, 3x minus 4 must be greater than or equal to 0. As long as that happens, I will have real answers. This expression will be real if 3x minus 4 is greater than or equal to 0. When I solve this inequality, I get x is greater than or equal to 4/3. I got that by adding 4 to both sides of the inequality and dividing both sides by 3. Now, if I end up with a number smaller than this, take the number 1, put it in here, that would be 3 minus 4, which is negative 1. Square root of negative 1 is imaginary, non-real, thus not allowed. So this would be my composition function with the qualifier that my domain will be all x's such that, oops, I'm going to run out of space there, x is greater than or equal to 4/3.